Okay, today we'll see about refraction of light. In the previous class we have seen about the reflection, right? Reflection, as I have told you, that if this is an object and if a ray of light hits the object, right, what happens? This ray of light bounces back, right? And this bouncing back of the light is what we call it as reflection of light. But when it comes to refraction, right, now what is this refraction? Let's say there is an object here, right? There is an object here. Now the ray of light, when it hits the object, instead of bouncing back, it passes through the object. But as it passes through the object, there is a bend in the path of light. Now you can see that over here it is traveling straight, and as it passes through the object, there is a bend here. Now this band of light, okay, this band of light, or this band in the path of light, when it passes from one medium to another medium, is what we call it as refraction of light. This is a very common experience, or common thing that you can see. For example, if you want to see the effect of refraction of light, what you can do is take a scale, put it in water, right? So the portion of the scale which is under water appears to be bent. Now that bending is because of what? That bending is because of refraction of light. Okay, there are so many phenomena which takes place in the atmosphere because of refraction of light. We will gradually come across all those things, right? But for the moment, remember that refraction of light is the bending of light, or the bend in the path of light. This is what we call it as the refraction of light. Unlike reflection, if you remember the law of reflection, right, we had two laws of reflection. It was the incident ray, the reflected ray, and the normal all lie in the same plane, and the angle of incidence is equal to the angle of reflection. That was the law of reflection. Today we will, basing on that, today we will also see about law of refraction, right? So what is this law of refraction? If you can turn to page number 183 of your textbook, okay, page number 183 of your textbook, over there you will find that it is the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Once again I repeat that the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. In order to explain the first law of refraction, let me take this example. So I have two mediums, right? One is air, okay, and the other is water, right? So this is the point where, let's say, up till here, right, up till here is air, and from here it gets into water. So this is the separating surface, right? Now when a ray of light comes from a source, so this ray of light, let's say over here you have the sun, okay, this ray of light coming from the source. Now this ray of light will be called as what? This would be called as the incident ray of light. Okay, this is the separating medium, right, or this is the separating surface. That is what in your book it is mentioned, to the interface of two transparent media at the point of incidence. So this is the point of incidence where the incident ray of light strikes the separating. Now what happens from air when it enters into, right, when it enters into water? What will happen to this ray of light? That is the question that we need to ask. Now in order to understand that, we need to imagine that there is a normal, right? There is a normal. If you remember in the earlier class I had told you what is normal. It's an imaginary line drawn to the surface, right, at the point of incidence, and it is perpendicular. Now this ray of light, okay, this ray of light, when it enters into into water, now there is one word which comes up that you need to understand. And before I explain all this, you have to understand two things. Let me explain that first and I will get back to this, okay? Don't mind for that, sorry. So I have got rarer medium, right? Rarer medium. Mm. I have got what we call it as rarer medium, and then another one is denser medium. Very often, right? Very often we will come across denser medium. Very often you will come across this word rarer and denser. Let's be very clear with what is this rarer medium and what is this denser medium. Okay. Now, if you take the case of air, right? If you take the case of air, the air. So if you can recollect that solid, liquid and gas. Okay. In case of solid, the molecules are very closely binded. In case of liquid, they are less closely binded, and in case of gas, they are very loose. Now, air, for example, over here, the molecules, you'll find that it's a gas, so they are free. They have sufficient distance. So the distance between the molecules is less, or it's very. I mean, the not less, but in case of gas, the distance between the molecules is very wide, right? The molecules are far away from each other, right? Very far away from each other. Now, in this case, what happens is it is easier for the light to travel through it. Okay. So now, rarer medium means the medium in which the molecules, right? The molecules are comparatively far away from each other, and in which or through which the light can travel easily. Now, when it comes to denser medium, okay, for example, if you take the case of solid, what happens? The molecules are very closely binded, very closely binded by what we call it as the intermolecular force, or IMF. So in that case, it will be very difficult for the light to pass through it. Okay, it will be difficult for the light to pass through it. Now, since the distance between the molecule is very close, right, very close to each other, or the molecules are very close to each other, it will be termed as a denser medium. Very important point for you to keep in mind, it is easier for light to travel in rarer medium, and it is comparatively difficult for the light to travel in a denser medium. So once you have understood what is this rarer and denser, rarer means the medium in which the light can travel easily, because the distance between the molecule is quite much, right? When it comes to denser medium, the medium in which the light cannot travel that easily. Okay. So now we come back. Okay, for understanding this denser and rarer, we come back to the topic. Now, when I draw a normal, please keep in mind here there is a this is air, and in air the molecules are quite far away from each other, so the light does not have any problem in moving through the gaps, right? When it comes to water, in case of, when we compare air and water, the water molecules, right, the molecules in liquid are comparatively closer to each other, so you can see here that it will be difficult for light to move through water. So basing on that, so when a ray of light coming from air, now over here air is what? Air is a rarer medium. Okay, air is a rarer medium, whereas water is what? Water is a denser medium, right? So when a ray of light travels from a rarer medium to a denser medium, what will happen? It will bend towards the normal. So you see, actually it should have gone straight, but what has happened? It has bent towards the normal, right? Now this ray of light which has bent, this is called as what? This is called as the refracted ray. Okay, so you have the ray of light coming from the source, which is called as the incident ray. The ray of light which has bent, it is called as the refracted ray. Okay, so the incident ray, the refracted ray, and the normal at the normal to the interface of two transparent medium. So interface of two transparent medium. What are the two transparent medium here? One is air and the other is water. All lie on the same plane. That is the first law of refraction, right? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This is also known as Snail's law of refraction, right? So what they are saying is the ratio of sine of angle of incidence to the sine of angle of refraction is constant, right? Is constant, and this is This is also called as what? This is also called as the Snail's law, right? Snail's law, which is same for any given color of light and a given pair of media. Now, media or medium. So, what is it? It refers to those substances through which light can pass through. Okay, medium, because light needs a medium to travel. So, you have air is a medium, water is a medium, right? So, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Now, uh, once again, so let us suppose that this is air and this is water, right? This is water, this is the normal. So when a ray of light travels from a rarer medium, this is air is a rarer medium, and towards a denser medium, right? What happens? It bends towards the normal. So the angle between the incident ray and the normal will be called as angle of incidence, and the angle between the normal and the refracted ray will be called as angle of refraction. Same like reflection. Okay, so the ratio of sine of angle I, that is angle of incidence, to the angle of refraction will always be a constant, and that is what we call it as second law of reflection, and it is also called as the Snell's law, right? Please keep in mind this law is true only when angle of incidence is less than 90 degree. If it is more than 90 degree, we will see what happens if the angle of incidence, right, if the angle of incidence becomes more than 90 degree, what happens, that we will gradually see. Okay, now the next question that comes to our mind, so we have, what have we seen? We have seen what is refraction, the laws of refraction. Before we also go into another topic, once again I would like to clarify something here. You will see here, once again, please keep this in mind. Air is a rarer medium, because through air light can travel easily, and water is a denser medium, because light may not be able to, or is not able to travel as easily in water as it is able to travel in air, right? So I draw the normal. Okay, I draw the normal. Please keep in mind, when a ray of light travels from a rarer medium into a denser medium, it bends towards the normal, right? There is a bending towards the normal, right? Please keep that in mind. Similarly, when a ray of light travels from a denser medium, right, from a denser medium to a rarer medium, it bends away from the normal. Please keep this thing very clear in mind. When a ray of light travels from a rarer to a denser medium, it bends towards the normal, and if a ray of light travels from a denser medium to a rarer medium, it bends away from the normal. I can write like this: when a ray of light travels from a rarer to a denser medium, it bends, right? Bends towards what? Bends towards normal, right? I hope you will understand. When a ray of light travels from a rarer to a denser medium, it bends towards the normal, and when a ray of light travels from a denser to a rarer medium, what happens? It bends away, right? It bends away from normal. So, and I have also explained to you what is denser and rarer medium. So the next question is, why light bends? Okay, why light bends? I have been telling you that in case of refraction, the light bends. But the question is, why does it bend? The answer lies in the distance between the molecules, right? Uh, See here, if you take the case of solid, right? If you take the case of solid, the internal arrangement of the molecule is, in case of solid, the molecules are very closely packed, okay? Very closely packed in this way, right? The molecules are very strongly held by a force which is called as the intermolecular force, or we also call it as IMF, right? If you take the case of liquid, right? If you take the case of liquid, you find that the molecules are not as closely packed as that in case of a solid, right? And if you take the case of gas, right? If you take the case of gas, you'll find that the molecules are very free and far away from each other. So this is the molecular, you can see here, this is the molecular arrangement in case of solid, this is the molecular arrangement in case of liquid, and this is the molecular arrangement in case of gas. Now you need to understand this molecular arrangement in various substances. And if you understand the molecular arrangement in various substances, you will be able to understand the concept of why actually light bends. Now if you take the case of solid, okay, if you take the case of solid, you will find that the molecules are very closely packed, so it is not possible for the light to easily pass through the spaces between the molecules. Okay, it is not possible for light to easily pass through the spaces between the molecules. Why? Because the molecules are very closely packed, and it is because of this reason, if it what happens is the speed of light decreases, the bending. So we are coming to that very important point, the bending. Okay, the bending of light is normally because of what? Is normally or is due to the decrease in the speed of light. Okay, now you take the case of liquid. When you see liquid, you will find that in case of liquid there are some molecular spaces, there are some intermolecular spaces, so light can pass through. I don't say that it will very easily pass through, but it can pass through easily as compared to solid, because there are spaces. So there is no much, there will be bending but not much, right? But if you take the case of gas, absolutely no problem. Okay, so if you really want to understand what what makes the light to bend, then you need to understand this concept. And here, if you take the case of solid and liquid, okay, which will be rarer and which will be denser? See, you take the case of solid, you find that the molecules are very closely packed, so therefore this is a denser medium. Denser means very close to each other. Whereas if you take the case of liquid, you find that the molecules are not so closely packed as compared to solid. Therefore this becomes what? This becomes a rarer medium. Now if you take the case of liquid, and if you compare, right, if you compare liquid and gas, okay, if you compare liquid and gas, which will be rarer and which will be denser? You see, in case of gas the molecules are far away, whereas in case of liquid the molecules are close. So since the molecules are close here, when you compare liquid and gas, you'll find that the molecules are close in liquid as compared to gas. Therefore liquid becomes what? Liquid becomes denser, and gas becomes what? Gas becomes a rarer. So the whole concept of which is rarer and denser depends on what? Depends on how closely the molecules are packed. Okay, how does this molecular arrangement affect the movement of light? That is what we are going to discuss right now. So you have what the next topic, we call it as the refractive index. What do you understand by refractive index? It is what? It, in simple words, is the ability, right? Ability of a medium, right? Ability of a medium to bend light. The ability of a medium to bend light is what we call it as its refractive. So, so far we have seen uh, what is refraction of light. Okay, what is refraction of light? And then we have seen the laws of refraction, right? And the molecular arrangements, right? The molecular arrangements, the molecular arrangements. Then we have seen about rarer, okay, rarer and denser, right? Rarer and denser medium. Clear? Okay.